All right, let's go. Number 10, HD189733b. In 2005, astronomers discovered a planet 63 light-years from Earth that appeared stunningly beautiful through their telescopes. HD189733b glowed a deep cobalt blue, reminiscent of Earth's oceans seen from space. For a brief moment, it seemed we had found a familiar sight in the alien cosmos. We hadn't. What we found was one of the most hostile worlds ever observed. The blue color isn't from water. It comes from silicate particles suspended in the planet's atmosphere. These are tiny fragments of glass, scattered throughout clouds of scorching gas. The temperature on HD 189733b reaches 1,700 degrees Fahrenheit, which is hot enough to vaporize most metals. But temperature isn't what makes this world truly nightmarish. The planet's atmosphere moves at incomprehensible speeds, winds exceeding 5,400 miles per hour, 7 times the speed of sound, tear across the surface in perpetual hurricane-force storms. These aren't vertical winds like Earth's tornadoes. They blow sideways, parallel to the ground, creating a horizontal maelstrom that circles the entire planet. And in those winds, it rains glass. The extreme heat vaporizes silicates in the atmosphere, which then condense into molten glass droplets. These droplets are caught in the hypersonic winds and flung sideways at speeds that would shred any known material. Imagine standing in a sandblaster loaded with molten glass, amplified 1,000 times over. What makes HD 189733b particularly unsettling is how it challenges our assumptions about planetary habitability. We've learned to look for blue planets as potential havens for life, worlds that might resemble our own. But this cobalt jewel in the cosmic darkness is a reminder that beauty in space can mask absolute lethality. Sometimes the most Earth-like appearance hides the most alien reality. When we look up at the night sky, we are conditioned to project our terrestrial comforts onto the void, assuming that familiar colors represent familiar environments. HD 189733b breaks that illusion entirely. It proves that the universe operates on a spectrum of violence that we are barely equipped to understand, turning the very aesthetic of a calm blue ocean into a supersonic nightmare of lacerating molten shards. Number 9. Zombie stars. In the cosmos, stars are expected to follow certain immutable laws. A massive star burns through its fuel, explodes as a supernova, and ceases to exist. Or so astronomers thought, until they encountered something that defies these fundamental rules of stellar physics, stars that have survived their own deaths. These zombie stars, officially known as Type 1a X supernova remnants, were first confirmed in 2013 when astronomers observed SN202Z in the NGC 309 galaxy. Unlike typical Type 1, a supernovae that completely obliterate their progenitor white dwarfs, these partial explosions somehow leave behind a surviving stellar core. This is a cosmic impossibility, according to our previous understanding of stellar evolution. What makes zombie stars particularly unsettling is that they've experienced what should have been a terminal cosmic event. The star undergoes a thermonuclear explosion powerful enough to outshine entire galaxies. Yet somehow, a portion of the star stubbornly remains intact, continuing to shine as if defying death itself. The leading theory suggests that during the supernova, the explosion becomes asymmetrical, ejecting matter violently in one direction while leaving part of the star intact. This partial supernova creates a bizarre stellar remnant, scarred, transformed, but still functionally a star. Perhaps most disturbing is that these cosmic undead aren't rare anomalies. Astronomers now believe up to 30% of what we classified as Type 1, a supernovae, may actually be these partial explosions with surviving stars. The implications are profound, forcing scientists to reconsider our most fundamental understanding of stellar death. Our own sun will eventually become a white dwarf. Could it too someday experience a partial explosion, becoming one of these cosmic revenants? And what does it mean for our understanding of the universe if one of its most basic processes, stellar death, can be circumvented? The universe, it seems, has found a way to cheat even the most fundamental forms of cosmic mortality. The existence of these undead stars paints a grim picture of the galaxy as a sprawling graveyard, where corpses occasionally refuse to lie still, drifting through the darkness as mangled, half-destroyed abominations of physics. Number 8. Cannibal galaxies. Our Milky Way galaxy has a violent secret. It is a cosmic predator, actively consuming smaller galaxies that venture too close to its gravitational pull. This process, known as galactic cannibalism, isn't just ancient history. It's happening right now as our galaxy tears apart and devours the Sagittarius dwarf spheroidal galaxy. The evidence of our galaxy's predatory past is written across the night sky. Long stellar streams, like the Helmi stream and the Virgo stellar stream, are the digestive remains of galaxies consumed hundreds of millions of years ago. Astronomers can identify stars that weren't born in our galaxy by their distinct chemical compositions and orbital patterns. They are immigrants from cosmic bodies that no longer exist. Most chilling is the implication for potential extraterrestrial civilizations. If intelligent life evolved in these consumed galaxies, their stellar remnants are now passing through our cosmic neighborhood. Calculations suggest that stars from the Sagittarius dwarf could be within just 50,000 light-years of our solar system. If any of these stars hosted advanced civilizations, the remnants of their technological achievements, or even their interstellar probes, could be silently drifting through our galaxy. The Milky Way's cannibalistic appetite will continue. In approximately 4.5 billion years, it will collide with the Andromeda galaxy, creating a massive elliptical galaxy. During this collision, star systems will be flung into intergalactic space or crushed together in cosmic pileups. What makes galactic cannibalism particularly unsettling is the complete erasure it represents. Entire cosmic ecosystems with billions of stars, potentially millions of inhabited worlds, all consumed and digested until they lose their original identity. Our own galaxy, the cradle of humanity, is built from the corpses of countless others. And someday, the atoms that make up our bodies may become part of a larger, more dominant cosmic structure that bears no resemblance to the spiral galaxy we call home. We live on a microscopic speck of dust, caught in the jaws of a predator that is itself destined to be eaten by an even larger cosmic entity. Number 7. Starless galaxies. When we think of a galaxy, we naturally picture a brilliant, swirling vortex of billions of stars, glowing with the combined light of countless nuclear fusion reactors. The very word galaxy conjures images of majestic spirals and glowing cores that break up the deep black of the universe. But the cosmos harbors structures that defy this visual logic entirely. In recent years, astronomers have identified massive gravitational anomalies lurking in the void, galaxies composed almost entirely of dark matter, with virtually no visible stars to illuminate their structure. The most prominent of these discoveries, Dragonfly 44, is roughly the size of the Milky Way. It has the same mass, the same immense gravitational presence, and it occupies the exact same volume of space as our home galaxy. Yet, it emits almost no light. It is a ghost galaxy. This is a massive phantom structure made of something we cannot see, touch, or understand. The terrifying reality of starless galaxies is what they imply about the true nature of the universe. We are accustomed to navigating the cosmos by the light of stars, safely assuming that where there is light, there is mass, and where there is darkness, there is only empty space. Starless galaxies prove this deeply comforting assumption is dangerously wrong. You could theoretically be traveling through intergalactic space, aiming your trajectory toward what appears to be a completely empty void, only to find your spacecraft suddenly caught in the immense, crushing gravitational well of a structure weighing 1 trillion solar masses. These invisible titans are not mere anomalies. Dark matter vastly outnumbers regular matter. It is the invisible scaffolding of the cosmos, the silent framework upon which the luminous universe is merely a thin, decorative layer. The existence of galaxies entirely devoid of stars reminds us of our own crippling sensory and technological limitations. We are like creatures living in the deep ocean, only able to perceive bioluminescence, completely unaware of the vast, crushing currents and colossal, unseen leviathans moving all around us. What other massive, invisible structures are drifting through the dark, waiting in the absolute cold? The universe is not mostly empty space. It is crowded with phantoms, massive and unseen, dictating the violent movements of everything we can observe while refusing to step into the light. Number 6. 55 Cancri E. 40 light-years from Earth, orbits a planet where mountains are made of diamonds and rain falls as crystallized carbon. 55 Cancri E, discovered in 2004, is roughly twice Earth's size and 8 times its mass. But its composition is unlike anything in our solar system. This is a carbon-rich world, a planet where the most abundant element isn't silicon or iron, but pure carbon in its crystalline form. The planet orbits so close to its star that surface temperatures reach 3,900 degrees Fahrenheit, hot enough to melt most metals. At these extreme temperatures and pressures, carbon doesn't form the soft graphite found in pencils. It crystallizes into diamond, the hardest naturally occurring substance known to science. Scientists estimate that roughly 1/3 of the planet's mass could be pure diamond, a layer potentially hundreds of miles thick beneath a graphite crust. To understand the scale, consider this. If the estimates are correct, 55 Cancri E contains more diamond than has ever existed on Earth throughout our planet's entire history. Mountains of crystallized carbon rise from diamond plains beneath skies where carbon vapor condenses and falls as diamond rain. It's a world built from the substance we value most, rendered utterly worthless by its abundance. What makes 55 Cancri E particularly significant is what it reveals about planetary formation. In our solar system, planets are primarily composed of rock and metal, with carbon existing only in trace amounts. But 55 Cancri E formed in a region unusually rich in carbon, possibly in a protoplanetary disk with different elemental ratios than our own. Its existence proves that planets can have wildly different chemical compositions depending on where and how they form. 55 Cancri E stands as a monument to cosmic irony, a world of infinite riches that will never be reached, never be touched, never hold any value beyond what it teaches us about the staggering diversity of worlds that exist beyond our small corner of space. It perfectly encapsulates the bizarre, deeply hostile conditions required to forge what humanity views as precious, reminding us that true value in the cosmos is entirely subjective and usually hidden within environments that would incinerate us in a fraction of a second. Number 5. Dead galaxies. A galaxy is essentially a vast, incomprehensibly complex machine designed by gravity to do one specific thing: turn cold gas into stars. As long as there is an abundance of hydrogen and helium, the machine continues to run, illuminating the darkness with brilliant, glowing stellar nurseries. But astronomers peering deep into the cosmos have found something deeply unsettling. There are massive, ancient galaxies, some of the largest structures in the known universe, that have simply stopped. They are known in astrophysics as quenched galaxies, and for all intents and purposes, they are utterly dead. No new stars are forming within them. They are populated entirely by aging, red stars slowly burning through their final reserves of nuclear fuel, waiting for an inevitable dimming that will leave the entire structure dark. The terrifying reality of a dead galaxy isn't just its current stagnant state. It's the haunting mystery of what killed it. Something profoundly violent and energetic must occur to permanently turn off star formation across a structure spanning hundreds of thousands of light years. How do you kill an entire galaxy? Astrophysicists believe the culprit often lies at the galaxy's center, a supermassive black hole that grew too fast and became far too greedy. As the central black hole gorged on surrounding matter, it ignited into an active galactic nucleus, a quasar, blasting unimaginable amounts of radiation and hyperfast jets of plasma outward. This apocalyptic feedback loop heated the galaxy's internal gas reserves so intensely that the gas could no longer collapse under gravity to form new stars. Alternatively, the violent galactic winds simply blew the lifeblood of the galaxy, its cold gas, out into the intergalactic void, starving the entire galaxy to death from the inside out. Looking at a quenched galaxy is like walking through a cosmic graveyard. The scale of the devastation is mind-numbing. We are witnessing the silent aftermath of an explosion or a suffocation event that eradicated the potential for trillions of stars and billions of habitable worlds. These floating corpses of red and dying stars serve as a grim, undeniable reminder that no structure in the universe, no matter how immense, is immune to death. Our Milky Way is still forming stars today, but it too harbors a supermassive black hole at its heart. The trigger that turns a thriving cosmic metropolis into a silent, barren tomb could be pulled at any moment on a galactic timescale, and every inhabitant within it would be utterly powerless to stop the suffocation. Number 4. Galactic graveyards. Moving beyond the localized death of a single galaxy brings us to an even more terrifying scale of cosmic destruction. True galactic graveyards. In the universe, galaxies are rarely solitary wanderers. They are inexorably drawn together by gravity into massive clusters, containing hundreds or even thousands of individual galaxies bound in a relentless gravitational dance. The Coma Cluster, for instance, is a colossal structure located over 300 million light-years away from Earth. But when astronomers look closely at the architecture of these massive clusters, they notice something deeply disturbing. The outer edges of the cluster are populated by blue, healthy, actively star-forming galaxies. But the closer you get to the center, the more the galaxies appear dead, red, and entirely stripped of their star-forming gas. These clusters do not just hold galaxies, they act as active, highly efficient slaughterhouses. The space between galaxies in a cluster isn't empty. It is filled with an incredibly hot, diffuse plasma, known as the intracluster medium. When a healthy, thriving galaxy falls into the steep gravitational well of the cluster, it must plunge through this superheated plasma at millions of miles per hour. The resulting friction creates a brutal physical phenomenon known as ram pressure stripping. It is a violent cosmic-scale headwind that literally blows the cold, star-forming gas right out of the incoming galaxy, leaving its stellar skeleton behind. Astronomers have captured breathtaking, horrific images of jellyfish galaxies actively plunging into clusters, leaving massive, trailing tentacles of glowing gas behind them as their lifeblood is violently ripped away by the sheer force of their orbital trajectory. Once that gas is gone, the galaxy is permanently sterilized. No new stars will ever form. The existing stars will slowly burn out, turning the galaxy into another dead husk, circling the cluster's dark center. It is a slow, inexorable execution. Entire galactic ecosystems, with all their potential for life, evolution, and civilization, are sterilized simply by the geometry of their path through space. If humanity were residing in a galaxy falling into one of these massive clusters, we would watch helplessly over millions of years as our night sky slowly ceased to produce new stars, our galaxy's raw material bleeding out into the void until nothing remained but ancient, dying red suns. The universe has evolved perfectly efficient mechanisms for mass extinction, operating continuously on scales that completely dwarf human comprehension. Number 3. Colliding black holes. In the hierarchy of cosmic horrors, nothing rivals the absolute physical violence of two black holes colliding. Black holes are the ultimate, terrifying endpoints of stellar evolution, regions of space-time where gravity has become so intensely concentrated that not even light can escape its pull. For decades, the merger of two such gravitational monsters was purely theoretical. We knew that binary black hole systems must exist, slowly spiraling toward each other over billions of years as they radiated away their orbital energy. But what happens in the final moments of that spiral defies all human imagination. When two supermassive or stellar mass black holes finally meet, they don't just crash into each other like planets or stars. They aggressively twist and tear the fundamental fabric of reality itself. In the final fraction of a second before they merge into a single, larger singularity, they are moving at significant fractions of the speed of light. The collision releases an amount of energy so incomprehensible that it briefly outshines all the stars in the entire observable universe combined. But this energy isn't released as visible light, or heat, or gamma radiation. It is released as pure gravitational waves, actual physical ripples in the geometry of space and time. Imagine dropping a heavy boulder into a calm pond, but the water is the fabric of reality itself, and the ripples are literally stretching and compressing the physical distance between objects as they wash over them. When the LIGO observatories detected the first gravitational wave in 2015, they recorded a distortion in space that was a tiny fraction of the width of a proton. But that faint signal came from two black holes, roughly 30 times the mass of our Sun, colliding over 1 billion light-years away. For a brief, terrifying moment, the power output of that invisible collision was 50 times greater than the entire visible universe. If such an event were to happen close to Earth, say within our own galactic neighborhood, the gravitational waves wouldn't just be an undetectable curiosity passing through scientific instruments. The sheer stretching and squeezing of space-time could theoretically impart enough energy to physically disrupt planetary structures, violently altering orbits and tearing apart anything caught in the intense spatial tidal forces. Colliding black holes remind us that space-time is not a fixed, empty, reliable stage where cosmic events occur. It is a flexible, highly dynamic surface that can be whipped into a violent storm by the most extreme objects in existence, threatening the structural integrity of everything it touches. Number 2. Hypernova remnants. In the 1960s, the United States military satellites, designed to detect nuclear explosions, began picking up mysterious bursts of gamma radiation from deep space. These events, now known as gamma-ray bursts, or GRBS, represent the most violent and energetic explosions in the universe since the Big Bang itself. A typical GRB releases more energy in a few seconds than our Sun will produce in its entire 10 billion year lifetime. The source of this extraordinary power was confirmed in the 1990s. GRBS mark the birth of black holes. They occur either when a massive star collapses at the end of its life, an explosive event often called a hypernova, or when two neutron stars violently collide and merge. The energy released is so extreme that it briefly outshines the rest of the visible universe combined. If a GRB occurred in our galaxy and was pointed directly at Earth, it would be visible in broad daylight, appearing as a brilliant flash in the sky before darkness fell across the planet. What makes GRBS particularly terrifying is their sterilizing power. The intense gamma radiation from a burst aimed at Earth from within 3,000 light-years would destroy our ozone layer, exposing the surface to lethal levels of ultraviolet radiation from the Sun. Models suggest that even a GRB from the other side of our galaxy could trigger a mass extinction event. Some paleontologists have proposed that the Ordovician extinction event, which wiped out 85% of marine species 440 million years ago, may have been caused by a distant GRB. The universe produces approximately 1 detectable GRB per day, with their distribution appearing completely random throughout the cosmos. In 2022, astronomers detected GRB2 2100009A, nicknamed the Boat, or brightest of all time, which originated 2.4 billion light-years away, yet was still powerful enough to disrupt Earth's ionosphere. Had this burst occurred within our galaxy, it would have caused a global catastrophe. GRBS serve as cosmic snipers, capable of eliminating life across vast distances with no warning. Their existence raises a troubling possibility. Perhaps the universe periodically sterilizes habitable worlds through these random bursts of gamma radiation, resetting the clock on biological evolution across entire galactic neighborhoods. There is no defense, no preparation, and no escape from a beam of radiation traveling at the speed of light. Number 1. Largest explosion ever observed. Deep in the constellation Ophiuchus lies a supercluster of galaxies located approximately 390 million light-years from Earth. It is here that astronomers discovered the aftermath of the single most powerful eruption ever recorded in the history of the universe. For years, X-ray telescopes had observed a strange, massive curved edge in the superheated plasma gas surrounding the cluster's central galaxy. It looked exactly like the edge of an immense cavity, but astronomers initially dismissed the idea because the sheer scale of the energy required to punch a hole that large was considered physically impossible by all known metrics of astrophysics. It wasn't until low-frequency radio telescope data was overlaid with the X-ray images that the terrifying truth became undeniably clear. The cavity wasn't a structural anomaly or a trick of the light. It was a physical impact crater. A supermassive black hole at the center of the Ophiuchus galaxy had gorged itself on an unfathomable amount of infalling gas, triggering a violent, explosive outburst of unimaginable proportions. This wasn't a standard supernova. This was an active galactic nucleus eruption that released millions of times more energy than even the most powerful gamma-ray bursts. The explosion punched a hole in the intergalactic plasma that is so unbelievably large you could fit 15 Milky Way galaxies side by side straight across its diameter. The amount of energy required to carve out this cavity is the equivalent of billions of supermassive black holes detonating simultaneously in the exact same location. To put this cosmic violence into perspective, if you took the total energy output of our Sun over its entire 10 billion year lifespan and multiplied it by 100 trillion, you would just barely begin to approach the energy released in this single cosmic event. What makes the Ophiuchus eruption deeply unnerving is what it tells us about the latent, slumbering monsters sitting at the centers of seemingly stable galaxies. These supermassive black holes can sit quietly for entire eons, completely undetectable, only to suddenly awaken and release energy capable of physically resculpting the architecture of entire galaxy clusters. Anything caught in the path of that plasma jet, entire galaxies, trillions of stars, countless potential biospheres, would have been instantly sterilized, their atmospheres violently incinerated, their planets bathed in lethal radiation before being torn apart by shockwaves. The universe is not a silent, peaceful void waiting for us to explore it. It is a theater of unimaginable, unpredictable violence, where events of cataclysmic proportion happen in the dark, leaving behind physical scars that dwarf our entire galaxy. It is the ultimate reminder of absolute human fragility. In a universe capable of explosive eruptions that can swallow 15 Milky Ways in a single breath, our existence is nothing more than a fragile, temporary statistical anomaly, quietly surviving only because we haven't yet been caught in the crosshairs of the cosmos.